So, good afternoon everyone. For today, our topic is all about isothermal process. When we say isothermal process, it is a process where the temperature remains constant. Like for example, this boiling water. When the water reaches its boiling point, which is 100 degrees Celsius, its temperature will remain constant. Now, for the formulas, yung pa rin yung anim na formula yung gagamitin natin, where heat is equal to integral of TdS limits from 1 to 2, which is also equal to change in internal energy plus work non-flow. In terms of work non-flow is equal to integral of PdB limits from 1 to 2. Then, change in the internal energy is equal to mCp delta T. Change in enthalpy is equal to mCp delta T. And work steady flow is equal to negative integral of BdT limits from 1 to 2. So, itong anim pa rin na formula yung ating gagamitin sa isothermal process para makuha natin or ma-derive yung mga formulas. Now, kapag sinabi natin constant temperature, syempre, T is equal to C and N is equal to 1. Diba, we have PB raised to N. PB raised to N is equal to C. Therefore, dapat yung equation natin dito ay, since yung N natin 1, PB is equals to C, or PB is equal to constant. Okay? So, ito siya. Now, yung kaibahan niya sa isometric and isobaric, parehas siyang merong work non-flow at work steady flow. Kapag sinabi natin work non-flow, ito yon. Work non-flow and work steady flow, ito yon. The work non-flow is the area under the PP diagram. Work steady flow is the area beyond PP diagram. Okay? Then, in terms of TS diagram, yung ma-form natin na area dyan ay tinatawag na heat. Okay, derive na natin yung formula. For the formula, of course, una dyan yung PBT relationship. So, sa combined ideal gas cycle, since constant temperature, makakancel lang yung temperature. Therefore, P1V1 is equal to P2V2. Sa work non-flow naman, is the area under the PB plane, yung pinakita ko kanina sa PB diagram natin, which is equal to integral of PdB limits from 1 to 2. But since sabi ko nga PB is equal to C, pwede natin itong may cross multiply, therefore P is equal to C over V. Okay? Now, yung P natin dito, the value of P, i-substitute natin dito sa formula or the working equation. Therefore, palitan natin yung P ng C over P. Work non-flow is equal to integral of C over V. Copy natin yung dV, limits from 1 to 2. Then, as a rule sa integral, lahat ng constant, pwede nating ilabas. Okay? So, since ang ini-integrate natin ay dV, ilabas natin yung C, which is constant. Therefore, ang working equation natin is equal to C integral of dV over V limits from 1 to 2. Okay. So, kunin natin yung integral nito. dV over V is equal to ln V. Copy natin yung C, limits from 1 to 2. Then, yung C natin, di ba, PB is equal to C. Ito yon. PB is equal to C. Pwede natin, yung C natin, pwede natin palitan ng PB. Kaya ang working equation mo dyan is PB ln V2 minus ln V1. Kasi sinubstitute mo tong limits. Therefore, by using the law of natural logarithm, madiderive natin tong equation na to. Work non-flow is equal to P1 V1 ln V2 over V1 is equal to, pwede rin siyang P2 V2 ln P1 over P2. Saan nakuha yung ln V2 over V1? Dito sa law of natural logarithm. Okay? Then, dito rin sa PBT relationship. Kasi pag kinross multiply mo yan, magiging P1 over P2 is equal to V2 over V1. Okay? Kaya itong working equation natin na P1 V1 ln V2 over V1, pwede natin siyang palitan ng P1 over P2. So, P2 V2 ln P1 over P2. Bali, apat yan. Pwedeng P1 V1 ln P1 over P2. Pwedeng P2 V2 ln P2 over V1. So, apat yung formula na madiderive natin sa work non-flow. Okay? So, since meron tayong formula na PB is equal to MRT, makaka-derive na naman tayo ng another formula. So, itong PB natin, papalitan lang natin siya ng MRT. So, M at R constant, kaya MRT1 or MRT2. So, therefore, work non-flow is equal to, palitan natin to ng MRT, MRT1 ln P1 over P2. Pwedeng MRT1 ln V2 over V1 is equal to MRT2, pinalitan natin to ng MRT2 ln V2 over V1 or MRT2 ln P1 over P2. So, bali pala ang formula ng work non-flow natin sa isothermal ay 8. Apat dito sa in terms of PB, apat sa in terms of MRT. Now, let's proceed to the heat. So, by the formula, anong formula ng heat? Heat is equal to delta U plus work non-flow. Since constant temperature, ano bang formula ng delta U natin? mCv delta T. So, kung ang formula ng delta U ay mCv delta T, therefore, delta T is equal to 0, delta U natin is equal to 0. Therefore pala, ang formula ng heat natin is equal to work non-flow. So, ito, pwede mo siyang gamitin sa formula ng para makuha yung value ng heat natin. And equal din siya sa work steady flow. So, mamaya ipuprove natin bakit equal yung tatlo na yan. Okay? So, next is the internal energy, which is Cv delta T is equal to 0 kasi ang delta T natin ay 0. Any number multiplied by 0 is equal to 0. Parehas lang din siya sa enthalpy, which is mCp delta T. Since delta T is equal to 0, therefore, enthalpy natin is equal to 0. Now, let's solve for the value of the entropy. So, saan natin makukuha yung formula ng entropy? Sa formula ng heat. So, since heat natin ay equal sa work non-flow, gaya nung pinakita ko sa inyo kanina, therefore, i-derive natin yung formula ng entropy. Okay? So, anong formula ng heat natin? Formula ng heat natin ay integral of TdS limits from 1 to 2. Ang formula ng work non-flow natin ay integral of PdB limits from 1 to 2. Okay. So, multiply natin by 1 over T yung both sides of the equation. So, yung T dito makakancel. Okay? Then, magkakaroon dito ng over T. Okay? Therefore, integral of, natira dito, ds na lang, limits from 1 to 2 is equal to P over T dB. Kaya na ba tong ma-integrate? Hindi pa, di ba? Kasi yung P natin ay yung P over T natin ay hindi siya related sa TV. So, ang gagawin natin is simplify pa natin. Meron tayong formula na PV is equal to MRT. I-cross multiply natin. Therefore, P over T is equal to MR over T. Okay? So, nirite natin siya in terms of MR over P. Para ilalabas natin tong MR, since constant yan, makukuha na natin yung integral ng ating entropy, which is integral of dB over B limits from 1 to 2. Therefore, delta S natin ay, copy yung MR, ln, V2 over V1 is equal to MR ln P1 over P2. So, merong mga problems na hindi itong formula ang ginagamit. Merong problems na ang formula na enthalpy ay Q over T. Okay? So, ayan tatlong yan. Kailangan natin yan sa mga example problems natin. Okay. Then, last formula is the work steady flow or WSF. Gaya nung equation natin kanina, di ba? Ang equation natin kanina ay heat is equal to work non-flow is equal to work steady flow. So, i-prove natin bakit naging equal yung tatlo. It is the area beyond PV plane. So, we have a general formula of heat is equal to delta PE plus delta KE plus delta H plus work steady flow. So, may mga problems na nine-neglect yung potential energy at the same time yung ating kinetic energy. Kasi, yung value lang naman nila ay minimal. Ibig sabihin, halos hindi sila nakaka-apekto dun sa process natin. Kaya, kalimitan, nine-neglect sila sa problem. Since yung delta H natin is equal to 0, kasi wala nga tayong change in temperature, therefore, Q natin is equal to work steady flow. Also, equals din siya sa ating work non-flow. Okay? So, dyan na-derive yung formula ng ating work steady flow. Okay. Sample problems tayo. So, number 1, during isothermal process at 88 degrees Fahrenheit, the pressure on 8 pounds of air drops from 80 psia to 5 psi gauge. So, nagmula siya sa 80 psi absolute, tapos naging 5 psi gauge. For an internally reversible process, determine the work non-flow, work steady flow if kinetic energy or change in kinetic energy is equal to 0. Find also the heat, delta U, delta H, and the change in entropy. Now, kunin na muna natin yung mga given. So, given natin temperature is equal to constant. We have T1, which is the initial temperature, also equals to T2, kasi nga constant temperature. So, 88 degrees Fahrenheit plus 460, kasi gagawin natin siyang absolute value. So, 88 plus 460 is equal to 548 degrees Fahrenheit. Now, for the mass, it is 8-pound mass. For the initial pressure, it is 80 psia. And for the final pressure, or P2, is equal to 5 psi gauge. So, para gawin natin siyang absolute, magpa-plus lang tayo ng atmospheric pressure, which is equal to 14.7 psi. So, 5 plus 14.7 is equal to 19.7 psi absolute. Now, required natin is work non-flow, work steady flow, heat, delta U, delta H, and delta S, or the change in entropy. Okay? So, for the solution, solve muna natin si work non-flow. So, from the formula na dinerive natin kanina, work non-flow is equal to, ang given natin ay M, mass, may given tayo na temperature, may given tayo na pressure. So, ang gagamitin natin ay MRT, ln P1 over P2. So, ang formula na gagamitin mo ay based doon sa given ng problem. Okay, we have mass. So, since yung medium natin ay air, meron tayong R ng air, which is constant yan. Ilan nga yan kapag English? Nasa around 53.34 foot-pounds per pound mass degree Rankine. So, dapat memorize yun na. Then, we have T1, we have P1, and we have P2. Okay? So, ang formula na gagamitin, nakadepende lagi sa given. So, direct sub, okay, yan yung sinabi ko, R ng air ay 53.34 foot-pounds per pound mass degree Rankine. Now, substituting all the values, we have mass of 8 pounds, R of 53.34 foot-pounds per pound mass degree Rankine. We have temperature 1 of 548 degree Rankine, and ln 80, which is P1 over the P2, which is 19.7. So, by cancellation of units, cancel natin yung R, yung pound mass. Ang matitirang units natin dito ay ano na lang, foot-pounds or foot-pounds yan na pag binasa. Okay? Therefore, kapag in-input natin sa calcu, ang lalabas natin na work done flow is equal to positive 327,708.834 foot-pounds. So, ang kailangan natin dito ay work done flow in terms of BTU. So, by conversion of units, 1 BTU is equal to 778 foot-pounds. So, cancel natin yung foot-pounds. Ang magiging work done flow natin ay 421.22 British Thermal Unit or BTU. Okay? Now, solving for the work steady flow, which is yung pangalawang hahanapin natin. Saan yung mouse ko? At work steady flow, based dun sa concept na ginawa natin kanina sa pag-derive ng formula, work steady flow is equal to work non-flow is equal to 421.22 BTU. So, no need to solve na ha. Kasi equal lang naman sila. In terms of heat, ganun din. Equal din sila sa work non-flow is equal to 421.22 BTU. So, mas madaling mag-solve ng isothermal kasi maraming equal na values. Okay? In terms of change in internal energy and change in enthalpy, they are both equal to 0. Kasi wala tayong delta T. And last, solving for the change in entropy, we have a formula of, yung gagamitin natin in terms of MR kasi ayun ang ating given. MRL and P1 over P2. Meron tayong M, meron tayong R. So, direct substitution lang siya. So, M natin is 8 pound mass. R natin is 53.34 foot-pounds per pound mass degree Rankine. ln P1 natin ay 80 over P2 is 19.7. Then, since ang kailangan nating value ay in terms of BTU, convert na natin diretso. 1 BTU is equal to 778 foot-pounds. So, by cancellation of units, cancel tong foot-pounds and cancel tong pound mass. So, matitirang units natin dito dapat ay BTU per degree Rankine. Therefore, delta S is equal to 0.7686 BTU per degree Rankine. Okay? So, clear? Proceed tayo sa second round. For the second problem, during a reversible process, there are abstracted 317 kilojoules per second from 1.134 kilogram per second of a certain gas while the temperature remains constant at 26.7 degrees Celsius. For this gas, Cp is equal to 2.232 and Cv is equal to 1.713 kilojoules per kilogram Kelvin. The initial pressure is 586 kilopascal for both non-flow. Delta PE natin is equal to 0 and delta KE natin is equal to 0. So, for both non-flow process, the turbine B1, B2, and P2, also the work non-flow, work steady flow, heat, and delta S, and delta H. Okay? So, kunin natin yung given. We have heat of 317 kilojoules per second. So, since sinabi is obstructed, meaning, rejected. Kaya negative sign ang ating heat. So, you have to be careful about the signs of the useful work and the heat. Kasi minsan, negative pala yung sign nila, nilalagay nyo positive. Mamamali kayo sa pag-solve ng problem. Mamamali yung mga values na makukuha nyo. Okay? So, you have to be careful about the signs. We have a mass of 1.134 kilogram per second. And the temperature, which is constant at 26.7 degrees Celsius. So, in terms of Kelvin, gawin nating absolute. Plus 273 lang yan, 299.7 Kelvin. So, given yung Cp, 2.232 kilojoules per kilogram Kelvin. Given yung Cv, which is 1.713 kilojoules per kilogram Kelvin. And initial pressure of 586 kilopascal. So, kanina yung units natin ay English, ngayon naman ay SI. So, kung mapapansin nyo yung mga problem natin, palaging ganun. English muna, tsaka SI para masanay tayo both units. Kasi both units lumalabas sa ating board exam. Now, for the required, hinahanap ay B1, B2, P2, work non-flow, work steady flow, delta S, and delta H. Okay? Okay. So, for the solution, hanapin muna natin yung B1, B2, and P2. So, paano natin nahanapin yung tatlong yan? Gagamitin natin ang ideal gas or combined gas equation. Pwedeng PBMRT, pwedeng yung P1 V1 over T1 is equal to P2 V2 over T2. So, and depende sa given, okay? So, since ang given natin ay meron tayong mass, meron tayong T, and pwede natin makuha yung R sa CP and CV, gagamitin natin yung PB is equal to MRT. So, solving for B1 muna, P1 B1 is equal to MRT1. Okay? So, P1, okay, given yan. V1, yan yung hinahanap. Meron tayong mass. Yung R natin, pwede natin makuha sa formula na R is equal to CP minus CV. Since given naman tong dalawa. Okay? So, given din yan. P1, given yan. So, direct sum lang pala to. So, kapag kinross multiply natin, ang magiging formula niyan, itong P1 cross multiply natin dito, MR T1 over P1 or M, yung R natin, pinalitan natin ng CP minus CB, M times CP minus CB times T1 over P1. So, direct sum, we have a mass of 1.134 kilogram per second, CP of 2.232, CV of 1.713. So, pinagsama ko natin, nilabas ko ang units nila, which is kilojoules per kilogram Kelvin. T1 natin is constant at 299.7 Kelvin over the P1, which is 586 kilopascal or pwede natin isulat as kilonewton per meter squared para makita natin yung ating cancellation of units. So, cancel yung kilogram. Okay? Yung kilojoules, pwede mo siyang i-write as kilonewton meter. Para yung kilonewton makancel mo, yung meter pupunta sa ilalim. So, ito magiging cubic meter. Okay? Kasi nasa over yan eh. Nasa ilalim yan yung mm. Kaya magiging cubic meter. May makakancel pa ba yung ating Kelvin? Therefore, yung matitirang unit dyan ay cubic meter per second, which is the volume. So, kapag in-input natin 0.301 cubic meter per second. Now, solving for the value of V2, gamitin natin yung formula ng heat since given naman yung ating heat, which is negative 317 kilojoules per second. So, heat natin is equal to work done flow is equal to P1 V1L and V2 over V1. Okay? Meron tayong P1, meron tayong heat, ayan, given. Meron tayong V1, kakakuha lang natin, L and V2 over V1. So, isang variable na lang ang hinahanap. Kaya na siya ng shift solve natin. Okay? So, Q is negative 317 kilojoules. P1 is 586 kilonewton per meter squared. V1 is 0.301 cubic meter per seconds. And Ln V2 over V1, V2 over 0.301. So, by cancellation of units, ang matitira na lang dyan, kilojoules pwede mong i-write as kilonewton meter, di ba? So, cancel yung kilonewton. Okay? Etong meter, cancel din yan. Dito, magiging dalawa na lang, then cancel. Then ito, 0.301 cubic meters, ay cancel na pala dito. Per second. Yan. So, dito mo makukuha yung units ng ating V2. Therefore, V2 is equal to 0.0499 cubic meters per second. Okay? Okay, solving for P2, we have P1 V1 is equal to P2 V2. Ito yung pinakaunang dinerive natin na formula. Okay. Then, cross-multiply natin to. Makukuha natin yung equation na P2 is equal to P1 V1 over P2. So, since kompleto naman yan, direct sub lang. So, P1 is 586. V1 ay 0.301 cubic meters per second. And the V2 natin ay 0.0499 cubic meter per second. Kaya, baka magtaka kayo paano naging, nawawala yung unit yan? Cancellation lang. Kasi same units lang naman. Kaya, unitless na yan na matitira natin ay kilopascal na lang. Same din dito sa kanina. Okay? Therefore, P2 natin is equal to 3534.79 kilopascal. Okay? Etong S natin, dito yan, sa heat natin. Di ba, kilojoules per second? Yan, dapat makakancel din yan. Tapos yung units ng B2 natin, makukuha natin dito sa cubic meters per second. So, lahat ng units dito na-cancel. Ito na lang yung natira, okay? Baka nalito kayo kanina. So, ganyan yun. Hindi lang nasulat yung per seconds ng heat. Kaya hindi ko na-cancel to. Pero meron yan. Okay? So, lahat ng units dito ay makakancel. Para makuha mo yung units ng B2, dito yan sa ilalim niya, which is cubic meter per second. Okay? Now, solving for the work non-flow, works steady flow, and heat. Since alam naman natin na equal sila, so yun na yan. Yun na yung sagot. Huwag nyo nang gawing komplikado. Okay? Kailangan kabisado yung concept. Kasi, sa board exam, isa lang yung hinahanap. Ganito yung tanong, tapos determine the heat. Determine the work non-flow, work steady flow. Like for example, yan yung tanong. all you have to do is, dapat, alam niyo yung concept. So, kung alam niyo yung concept, hindi na kayo magsusolve. Makikita niyo na sa choices niya na negative 317 kilojoules per second. So, mas alam niyo yung concept and principle ng topic, mas may advantage kayo. Okay? Mas mapapabilis kayo mag-solve. Okay. So, for delta S and delta H, so since ang given natin ay heat and temperature, ayun yung gagamitin natin. Ito yung gagamitin natin na formula. Delta S is equal to Q over T. Where heat natin is negative 317 kilojoules per second and temperature natin ay 299.7 Kelvin. So, walang makakancel na units. Ang units natin na change in entropy is equal to negative 1.058 kilojoules per Kelvin seconds. Okay? Then, last is for the change in enthalpy is equal to 0 kasi wala tayong change in temperature. Okay? So, almost same lang naman sila ng concept ng isometric and isobaric process. So, medyo madali lang to. Then, last problem, air flows steadily through an engine at constant temperature, 400 Kelvin. Find the work per kilogram if the exit pressure is 1/3 of the inlet pressure and the inlet pressure is 207 kilopascal. Assume that the kinetic and potential energy variation is negligible. So kapag may mga ganitong problem, eto lang naman yung nagpapalito sa mga estudyante. The pressure is 1/3 of the inlet pressure. And the inlet pressure is 207 kilopascal. So kailangan pag magsosolve kayo ng problem, magaling kayong mag-analyze ng sentence or magaling kayo sa advanced algebra. Kasi, di ba, doon naman tayo na sanay ng problem solving. So, i-ano natin yung given. So, meron tayong given of temperature at 400 Kelvin. Okay, no need na gawin natin ang tawag din? Standard kasi ano na siya, Kelvin na. Okay? Then, if the exit pressure, di ba ang exit natin ay P2 lagi, kasi pressure yan, P2. The exit pressure is, kapag may nabasa kayong is, laging equal yan, 1/3 of the inlet pressure. 1/3 of the inlet pressure. So, ganyan lang gumawa ng equation. Huwag nyo nang pahirapan yung inyong sarili. Okay? The exit pressure, susulat mo yung P2. Kung may nabasa kang is, equal yon. Kung may nabasa kang was, equal din yun. 1/3, copy mo yung 1/3 of the inlet pressure. Ano ba inlet natin? Laging 1. 1 is the inlet, 2 is the exit or exhaust. And the inlet pressure is 207 kilopascal. So, binigay din niya yung inlet pressure. Ano nga yung inlet natin? Laging 1. So, P1 is equal to 207 kilopascal. So, assume natin na ang ating kinetic energy and potential energy is negligible. So, required work none po. So, kapag sinabing negligible, delta KE and delta P is equal to 0. Okay. So, base dito sa given, anong formula ang gagamitin natin? So, meron tayong temperature, meron tayong pressure, ang hinahanap ay work non-flow. So, anong formula kaya to? Gamitin natin yung P1B1, no? P1B1L and P1 over P2. Kasi meron kang pressure. Ang hahanapin mo na lang ay B1. Pero pwede rin namang MRT, no? Pwede rin yun, pero ito na lang siguro yung gamitin natin. P1, B1, ln B1 over P2. Okay? So, gamitin natin yung condition ng problem where P1 over P2 is equal to 3. Therefore, solving for B1 in terms of PBMRT, we have, i-cross multiply lang natin to, makukuha natin yung P1 is equal to MRT1 over P1. Where yung R ang may mas pa tayo. Wala, no? So, nineglect natin yung mass. Okay? So, per unit mass to. So, yung R ng air natin is 0.287 kilojoules per kilogram Kelvin. Yung T1 natin ay 400 Kelvin. Then, P1 natin ay 207 kilo Pascal. So, since nireglect natin yung mass, pwede mo siyang i-write as B1 over M or small b1 lang, no? So, per unit mass siya. Therefore, B1 natin ay 0.555 cubic meter per kilogram. So, paano na-derive yung units natin? Kilojoules, pwede mo siyang i-write as kilonewton meter. Cancel yung kilonewton. Cancel yung Kelvin. Then, yung meter mo, pupunta sa ilalim. Okay? Kaya, V1 mo ay cubic meter per kilogram kasi may natira pang 1 kilogram. Now, solving for the work non-flow, since kompleto na yung given natin, direct sum na lang. Work non-flow is equal to P1, which is 207 kilonewton per meter squared. Yan yung KPA. Is equal to 0.555 cubic meter per kilogram. Then, ln, 3. Saan galing yung 3? Sa P1 over P2. Kasi ln P1 over P2 is equal to 3. Ayan. Okay. So, mas madali pa nga pag may ganyan ng problem. Kasi hindi mo na isa-solve yung value ng P2. Ilalagay mo na lang automatic dun sa my ln. Therefore, work non-flow is equal to 126.214 kilojoules per kilogram. Okay? So, that's all for today's video. Stay safe and thank you.